ladies and gentlemen, we are moving on to the moon. All right, so the moon, we're going to be following on review book pages 71 to 73. Okay, for those of you who want to follow along. Look how tiny the moon is compared to us. It's so small and cute. Okay, now let's talk about the moon. The moon is the only natural satellite that the Earth has. Now, if you look on your night sky app, which you all have at this point, right? Come on, load, right? You see all those little purple dots? Those are all man-made satellites, okay, that are in space, that are orbiting us, right? The moon is the only natural one that we had nothing to do with, okay? Now, I guarantee you your religion teachers at some point have told you that science and religion don't always see eye to eye, right? And that if you want to believe, you can believe whatever you want, you're entitled to do that, but you just need to learn these dates here, because the church says that the Earth is only a couple thousand years old. I'm telling you that the moon is about 4.5 billion years old, which means that the Earth must be older than that. So I don't care if you believe it or not, you just need to know the dates, and you just have to go with it for this class, okay? We're not judging. Nobody's judging. Everybody's entitled to their own opinion, but the moon is about 4.5 billion years old, and I'm going to prove it.
Wait, Miss Gonzalez?
Yes, sir?
When it says the moon is Earth's only natural satellite, what is meant by like satellite?
So satellite means that it orbits around us, okay? The fact that it's its own natural satellite, it means that it does it on its own and there's nothing man-made about it. Okay, the satellites that we have up there right now, the ones that control your cell phones, your TV, stuff like that, those we put up there. Okay, so it's the Earth's only natural satellite, as in it does it on its own. It did it on its own. We didn't throw it up into space and hope that the gravitational pull actually worked. Okay, speaking of that, the reason why it stays orbiting us is because of that natural attraction between the moon and the Earth's gravity. So the moon's gravity is going to be attracted to the Earth, and the Earth's gravity is going to be attracted to the moon, which kind of holds them in place, which is how the moon will actually go around. All right, so the moon, look, it's got some dark spots, some light spots, and then there's these like things, little pock marks on there. What are those pock marks called? What are these divots called, guys?
Craters?
Yeah, they're craters, exactly. Does anybody know why they're formed on the moon?
Meteorites that hit the moon?
Right, meteors, other things, other space stuff. So there's space dust, asteroids, comets, all kinds of fun things that are in space at all times. So those rocks and stuff can actually come and hit the side of the moon. Why does the moon have all of those, but the Earth does not? What does the Earth have that the moon does not?
Break down in the Earth's atmosphere.
Perfect, right? It does not have an atmosphere. We have an atmosphere. You guys have been learning about it this whole time, right? We have an atmosphere, but the moon does not, which is part of the reason why the moon is not habitable right now. We may do something later on that can make it habitable, but right now we'd be in complete danger every time that something came near us, right? There are space rocks and stuff that do come into our atmosphere towards Earth, but they never hit us, or they get to be so tiny that they don't do any damage. So that's the biggest difference between the moon and the Earth, right? All right, so let's talk about some features about the moon. We were just looking at that picture, right? That picture had light spots and dark spots and other fun things, right? Well, there's something that you can't see, is that they are inferring that the moon's interior is going to be similar to Earth. Okay, we know that the Earth's interior has layers, right? We have the inner core, the outer core, the mantle, the crust, the lithosphere, right? Those are all layers. And they're saying that the moon's, is similar to the Earth's. Interesting, right? We said that the moon's surface is covered with craters, which are caused by meteor impacts. Okay, so basically giant space rocks. Okay, so I'm going to show you guys a little clip, all right, about the moon. I'm going to also post it to Google Classroom for you guys so that you can have it under where it says videos from class. You are responsible for taking notes during this time, okay? So if you want to watch the video and take notes while we're watching the video, or watch it later and take notes and just watch it for now with us, but I am going to try and stop it so that you can, oh, it's already there, so that you can see it. Okay, so it's got to be on 3:10. Where are you? All right, you ready? Can you guys see this on the screen? So, where are you? So, basically, right, from looking at this, right, the moon was formed by the fact that a different planet hit into the Earth, and at that point combined with the Earth and spewed out a whole bunch of the Earth and Theia's particles into the outer space, basically. It gets caught up in the Earth's gravitational pull and starts to revolve around us. As it revolves, all of that space crap basically knocks into each other, right, and starts to rotate on itself. When it starts to rotate, it picks up a gravitational force of its own and starts to pull in more and pull in more and pull in more. And the more that coalesce together, basically that's how our moon was formed. So the moon is made up of part of Theia and part of the Earth. Okay, it was created by the combination of the two. Okay, which is why they think that the moon has similarities to Earth. They don't think it. I want to prove that they actually know it. All right, so I told you earlier that there are some dark sides and some light sides, right? The dark sides of the moon are called Marias. Okay, these Marias are basically remnants of lava flows that existed at one point. You saw from the video that when the moon was first created, it was basically made out of lava, and then it cools down over time. Okay. The light areas are known as lunar highlands, which are basically mountain ranges which are made up of lighter colored rocks. Okay. So what I may ask of you when it comes to this stuff is, what are the light areas called? Why are they light? What are the dark areas called? What do they say they used to be? That kind of stuff. I'm not going to give you a picture of the moon and say to you which are the Marias, which are the lunar highlands. I'm not going to do that. Okay, so it's mostly because the Marias are cooled down lava flows, and you can actually see that. They use stuff that we know on Earth. After a volcanic eruption, as the lava goes through, it actually creates like a little divot that kind of reminds me of a water slide. Okay, but it's a burnt through the ground water slide, and that's pretty much it. All right, guys, you good with this? Can I move on?
I'm almost done copying.
Okay, let me know when you're done, please.
Ms. Gonzalez, I have a question.
Sure.
Does the moon change every single year? Because, like,
Change what?
like anything about it, like because I heard it was like the moon's like only 14,000 miles away from us, correct? That's what I mean. Miles away
That's
from
what it used to be when it first was formed.
Oh, so see exactly. So it changes. Like the moon always changes. Like how far it is from us or close it is?
Well, the whole thing is that the universe is still expanding. And when it was 4.5 billion years ago, there's a huge change between then and now, as in how close everything is. They're further apart. We're going to get to that soon, though.
I'm done copying, by the way.
Thank you. Okay, so here we have a picture of a moon rock. So this is one way that they know that the moon is made up of the Earth, okay, or is made up of things that are similar to the Earth. Because when they analyzed this particular rock, they found minerals that are in common with Earth's minerals. So the fact that they have that one piece of rock has stuff made into it that is similar to those that are on Earth led them to believe that the moon must have been birthed, basically, from the Earth. Okay, so the way that I said it in another class was basically the moon is the baby between the Earth and Theia, right? You don't have all of your features in common with the mom. You don't have all of your features or characteristics in or similarities to your dad, but you're going to have a little bit of both, right? That's basically what this moon rock is showing us, that it's a combination of the Earth and Theia. And no, Theia does not exist anymore that I know of.
Wait, what's Theia?
Theia is the other planet that hit into the Earth that started the moon. That was the thing that was coming closer and closer and closer and closer to the Earth until eventually it hit it, and there was that explosion. Then that explosion, those pieces revolved around the Earth and created the moon. Okay, so here's where it gets a little bit of tricky.
I didn't finish copying the last slide. Thank you. Okay, I'm done.
All right, so this is where it gets tricky. All right, if you look at Earth Science Reference Table, page 15, it does have a section for the moon at the bottom, and it gives you the period of revolution and the period of rotation. What it doesn't give you is the phase period, or the period in which phases take place, and how long that takes to go from a new moon to a full moon and back to a new moon. All right. Earth revolves and rotates about 27.33 days. It takes the moon 27.33 days to go all the way around the Earth one time. Okay? The result of this is that the same side of the moon is always going to face Earth. Okay? However, your phase period is about 30 days. So in order to go from a new moon all the way around to a new moon again, it takes about 29.5 days, or approximately 30 days. That's why we have about 30 days in a month. Ooh, excuse me.
Wait, so for the Earth to rotate on its axis, it takes 27
This is all about the moon.
Yeah, I meant the moon. So
Yeah.
for the moon to rotate on its axis, it takes 27 days, and then for it to rotate around the Earth, it takes 29.
Remember, revolve means that it goes around us, and rotate means on its axis. But yes, you would be right.
Yeah, that's right.
Mm-hmm. Right. But from our perspective, it takes about 30 days for it to go completely around us. So why is that? Okay. It has to do with the fact that the way that we see the moon is based on the sunlight. So the sun is the big energy source we have inside of our solar system. The sun, the way that we actually are able to see the moon is that the sun's light reflects off of it to us. So it's from our perspective that the moon is in the new phase or the full phase. Okay? The moon itself never changes size. It doesn't disappear. It's just from our perspective that it looks like it's changing shape. it looks like it's disappearing. Okay, so you need to really understand that it's all about the fact from our perspective on Earth, what things look like. Okay, you guys ready?
Almost.
Okay, let me know when you're ready.
Wait, so because of our perspective, that's why it looks like there's 30 days?
It looks like it takes 30 days for the moon to completely revolve around us.
Okay, I'm good.
Okay. All right, so let's look at this little diagram here. All right. So we have the sun on the right, the moon in the middle, the earth is green. All right. In this particular location where you have the sun, the moon, and the earth, this is where you have a new moon phase. In other words, it looks like the moon has disappeared or that the moon is completely black. And the reason for it is because the sunlight is being blocked by the moon. Okay, so from our perspective, it looks as if the moon is blocking the sunlight at night. Okay, now, as we are revolving around the sun, the moon is revolving around us. So this right here, this diagram right here, is 27.33 days later. So the moon did one full revolution around us. But look at the location, right? If the sun is shining down in this direction, the moon is not blocking completely the sun from the earth, right? So that means that we're going to see a little bit of the moon on this side lit up. Okay, what has to happen is the moon has to move an additional 2+ days, okay, to then be in the same location from our perspective that it was in this part of the orbit. Okay, so to go from here all the way around to here, to do one 360-degree revolution, right, it takes 27.33 days. But for it to re-enter the new moon phase, it takes an additional 2 days to get there. Okay? Something I did earlier with my earlier classes. Where are you guys? You're here. Okay. I didn't just go into the dark to go into the dark for fun times. Okay? Here is our sun. Right? See how it's nice and bright? I'm probably blinding some of you guys. I'm sorry. This is going to be our moon. We're going to pretend that this is our moon, right? If it's shining on it, it looks like that, right? That would be a full moon phase, right? The whole thing is in the light. Now, when it is in the new moon phase, it's like that. You see how the whole thing is pretty much dark? Yes? No? Maybe? Yes? Hello?
Yes.
Yes.
Ooh, you just answer me. It takes like 3 seconds. Okay, so, right? So if this goes all the way around the Earth and lands in the exact same position, but the sun is here. And the reason the sun is there is because it is revolving around the Earth as the Earth is moving around the sun. Notice how over here, there's a little sliver of light that's being reflected off of the moon. You see that right here? So from your perspective, or the perspective on Earth, this is not a new moon until it moves an additional 2 days. You see that? Because that's what happens. Since the Earth is revolving around the sun at the same time that the moon is revolving around us, the moon has to play catch up to be back in the new moon phase. You guys get that? Yes, no, maybe, somebody? Marco? Anybody?
So Miss,
Yeah.
Does that make sense?
so we need like the moon need 2 days to get the full moon, the new moon again, right?
Exactly. It needs 2 more days just to do, it takes 27.33 days for the moon to go 360 degrees, but it takes 29.5 days for it to get into the original position where it could be a new moon phase from our perspective. So the phase period is approximately 30 days, where the revolution period is only 27.33 days. Do you guys get that? So it needs the extra 2 days to be able to get into a location where it blocks the sunlight. And when I say block, it's very loosely using the term blocking the sunlight.
Wait, I'm a little confused.
Sure. Help me out here.
So it takes 27.33 days for what?
For the moon to go 1 full revolution around the Earth to land here again. So it'll go 1 full revolution around the Earth to land here.
Okay.
Okay?
Okay.
But because we're also moving around the sun at the same time, right? Even though this is the exact same location here as it is here, right? It's not in terms of where the sunlight is. Here, which I was showing you with my phone and the tape measure, right? There was a little bit of sunlight off to the side here from our perspective. It was not in the new moon phase, okay? But when you are here and in almost a direct line here, that's when it would be in the new moon phase. And that's what you were looking for. So the phases, or the phase period, is based on how to go from a new moon to a full moon back to a new moon, okay? But the period, and that takes about 30 days approximately, right? But to go from this location all the way around to this location, it only takes 27.33 days. But to get the next new moon phase, it needs to be here. Okay, so the period of phases is going to be approximately 30 days, where the period of revolution and rotation is only 27.33 days. So the phase period is based on our perception on Earth, okay, where the period of revolution is by fax. Okay? Anybody have any other questions? Yes, no, maybe. Okay. The bell is going to ring in a second. So if you guys don't have any more questions, I have extra help today. Don't forget that. If you have any personal questions, you can ask me. Okay. If not, I will see you guys tomorrow for lab.
Okay, bye.
Bye.